Hello everybody and welcome back. It's Root Beer here and I'm going to do some more basic straight edge and compass constructions. So we've got, we don't have our straight edge selected. There's our straight edge, the infinite line tool, and the circle with center point and another point the circle goes through specified as our straight edge and compass respectively, and we're going to construct something. What are we going to construct, you ask? Let's think. How about we construct a circle through 3 given points. So this circle is a very nice basic object, and maybe you've heard some things like between any 2 points you can draw a straight line. And that's true, but with a straight edge that's kind of boring and obvious. But it's also true that with any 3 points you can construct a circle going through them, assuming these 3 points don't all lie on a line. So I'll show you how to do that. First I want to name my points just so I can refer to our starting points. So we got our A, B, and C, and we are going to, we don't need to draw these lines in here as a setup, but if we draw these lines, what I'm going to do is I'm going to take these line segments A, B, and B, C, I'm going to perpendicularly bisect them. If A, B, and C are on the same circle, BC is a chord of that circle. What does a perpendicular bisector of a chord do? Well, it goes all the way through the center. If I perpendicularly bisect AB, also a chord of the circle, we should get the same thing. And where those 2 lines intersect, it's going to be the center of our circle. So let's perpendicularly bisect. Again, you didn't need to draw AB, but I'm doing it for visual appeal. So B to C, and we'll single out those points. I'll have to zoom out ever so slightly to do that. Now we draw these perpendicular bisectors through these given points, these points that we've created, and they will intersect in exactly one place. Notice that if A, B, and C were on the same line, these perpendicular bisectors would both be perpendicular to the same line and therefore parallel. That's why 3 collinear points do not all lie on a line, but here it is, the center point of our circle. And now we just take it to any of these points. B to C, if I go to C, you can see it lies on B and A. If I go to B, it lies on A and C as well. Or I should say A and C lie on them. If I take this, draw the circle through A, what do you know? B and C are also on there. So we're going to hide our work because we want the end result. We want a clear picture that we can admire. Okay, and there is everything there. And we're even going to take the time to change the circle. Usually I change a line segment. We're going to make this a, we can make a bright red circle. There it is. Okay. And you can see as we move C around, this thing gets bigger. We'll zoom out a bit. Bigger. It even flips around. As we take B, we can move our circle. As B gets closer, this circle gets bigger, and then suddenly it's on a line. And if the program were incredibly precise, this circle would disappear. But no worries. But there is one circle for any 3 lines that aren't on, or any 3 points that aren't on a line. Okay? And so when you look at this sort of animation, as C moves, it slowly becomes a giant line. There's some higher math. I'm talking about things like Riemann spheres and complex analysis, where circles and lines are basically the same object, which is very interesting stuff. Nothing I'm going to talk about certainly in these videos. This is all about constructions with straight edge and compass, and we have done that. We have a mighty circle here. So hopefully you guys enjoyed this. This is another pretty basic construction built off our perpendicular bisector construction, and I like this one. And it's used to build some other pretty interesting stuff. In fact, the 3 points and the unique circle going through them, this is one of the easiest cases of a problem called the circles of Apollonius, which is actually, several problems have that name, but there's a nice one that maybe I'll do it in the future that says if you have 3 points, you can draw a circle between them. If you have 2 points in a line, you can draw a circle that's through the points and tangent to the line. If you have 2 circles in a line, you can get another circle that's tangent to all of them. It's some pretty nifty stuff, and I like it. It's kind of complex. I'll see where we go with this. But for now, we've got ourselves a circle through 3 points, and I think that's just great. And hopefully you do too. If you do, feel free to throw a like on the video. But either way, I'll see you guys for more math in the future.